हेलो। हाँ, गुड मॉर्निंग। जनवरी फरवरी और फिर जुलाई और अगस्त का चालू किया। अभी उनको मैं बोला कि अभी आपका प्रॉब्लम मिल जाता नहीं है। क्या बोल रहे कि वो मार्च अप्रैल में और चार का सर्विस दे सकते हैं तो अच्छा होगा करके। नहीं तो ऐसा कुछ लिख के कि अपलोड वगैरह नहीं हुआ है करके सब लिख सकते हैं। कर्म करके सब बात तो नहीं हो रहा है। इनको डांस नहीं मिली। उनको बोला आज आप प्लानिंग ठीक है। तो उसमें वो इम्पैक्ट नहीं है। नहीं अगर अगर देखो मेन तक ये है जिनका वगैरह अच्छा मतलब अपना ऑनलाइन अपना 3 जुलाई से चालू है तो उधर तक का अपना ये जाएगा ना तो और सब ठीक है ना सर जरा देख लो सर So we were discussing non-confining and we had finished. Is the screen visible? Adnan, can you see this electrochemical machine? Hello,
Yes, sir.
Yes, sir.
hello.
Yes, sir. Yes,
Yeah,
sir.
we can. Yeah. So electrochemical machining is used for your machining these complex blades. And look at setup. This drawing is very important. This is electrochemical machining. Just have a look on this drawing. This is not important. This chemistry is not important. Short note can come. Electrochemical machining described. So you have to draw this diagram. This we have already discussed. So that electrochemical machining it is nothing but reverse of electroplating. Reverse of electroplating. Now where is your workpiece? This is what is your workpiece. I am reading this again. I am showing this again. We already discussed. Workpiece is positive. So now the erosion will happen at the workpiece, and erosion will happen as per the shape of the workpiece. And this is how it can be, these are the turbine blades, very complex component. We discussed this also, electrochemical machining, what are the applications. So now we were here, that is electrochemical grinding. So again, it is similar to your electrochemical machining, but it is fast. Why it is fast? Abrasive action. But there is a abrasive action. Material removal rate is 0.2 centimeter cube per minute, and then surface finish is in the range of 0.2 to 0.4 microns. Normally, the question on this may not be asked. There are a lot of things to ask. That's right. Then ultrasonic machining. So here again there is a abrasive slurry. I'll zoom it. This is so there are vibrations, up and down vibrations. So the tool is vibrating as well as there is a abrasive slurry which comes through the nozzle, and then vibrations, for the vibrations to occur, there is a transducer which converts electrical energy into mechanical energy, that is vibration energy. And because of the vibrations and the abrasive slurry, abrasive matlab this silicon carbide or aluminum oxide, a material is eroded, and then erosion will happen in the shape of the tool. So vibrations is in the range of 16 kilohertz and more, 16,000 hertz. Piezoelectric crystal is used, and slurry is nothing but it is a mixture of water and abrasives. Abrasives which can be used is aluminum oxide and silicon carbide and boron. Abrasive slurry is recycled. Is recycled. It is cooled as well as recycled so that the wastage is avoided. These are the capabilities. So the material removal rate is 3 meter cube per second. So it is slow. Accuracy of 5 microns is possible. Then rate of the tool is 20 millimeter per minute. But that is in soft materials only. And obviously, if the material is hard, and penetration rate will be very slow. There is a difference between accuracy and surface. I hope you are aware of this, the difference between accuracy and surface finish. The power of ultrasonic machines are less, so that's why those ultrasonic machines are very compact. So many times, the tabletop models, small machines are available, and the applications, the popular applications of ultrasonic ma- machining is basically for the cleaning or for the deburring. The component which cannot be deburred, manually. hmm, I mean, if you try to do the deburring manually, then the component may get damaged. So in such case, ultrasonic machining is used. So they have power from 20 watts to 2 kilowatts. So not so heavy machines. Applications are many. You can do hard material machining like your glass, ceramic, can be used for machining wire drawing dies, can be used for drilling of holes by dentists on tooth, and so on. This we have already discussed, but I'll just quickly go through this because the sketch you can draw this additional sketch in water jet and abrasive water jet machining. So in case of abrasive water jet machining, water and abrasive, water and abrasives which are directed toward the workpiece and used for machining. Whereas in case of exclusive water jet machining, only water is used for machining. And obviously, in case of water jet, and in order to reduce that pressure, we go for abrasive water jet machine. So the pressure requirements are less because the pressures of 400 megapascals are very high. Advantage of water jet is no heat is produced, no thermal stress, so there are no damages. Again, it has many applications. Water jet also. So imagine water jet is nothing but like your CNC milling only. So in abrasive jet machines, you have you know abrasive particles which are carried by filtered gas or air at high pressures. Now here in this stage, this is very important. I suggest you go through this. Necessary, you write it down. Hmm. Again, I am telling you don't have to learn these, numbers, but you must understand what is what on this for a minute. So by now you are aware, of all these machining processes. Like now, this is your conventional machining. That is your normal machining. In this machining, you have material removal rate (MRR) of 825 millicube per second. Then surface finish is around half a micron to 5 microns. Accuracy, what you can get is 50 microns. Consumption is 30 kilojoule per centimeter cube per minute, and then penetration is around 1 to 5 millimeter per minute. Now, this is by this, that is plasma arc machining. So these are all unconventional machining. In plasma arc, you have material removal rate of 2700 millimeter cube per second. It is very fast, but the surface finish is not at all tolerable. I mean, it's of no use. So it is very rough. It is very rough. Accuracy is also very bad. See, 250 microns, and that's why plasma arc machining has very less applications. Power consumption is no doubt it is less, but the problem is the surface finish which is rough, accuracy which is poor, 250 microns. Because of these two factors, it is used in limited way. Then next is your electrochemical machining. The material removal rate is 550 millimeter cube per second. The surface finish is good. Accuracy is also not bad. Power consumption is also average, and penetration is around 12 millimeter. So this is your electrochemical machining. So it has average finish accuracy. So electrochemical machining is oftenly. Then next is followed by EDM, which is most popular after your conventional machining because it can be used for hard metal. Material removal rate is also good, 14 millimeter cube per second. Finish is not bad. Accuracy is also good. Power consumption is also less. Penetration is also good enough, 12 minutes. And the biggest advantage of EDM is that it for hard material, and the limitation is that it is used only for conductive materials. Conductive research is going on to perform EDM on non-conductive material. So this was the most important. Now we'll go for EDM, which is very important from examination point of view, as well as knowledge point of view and application point of view also. Now, one thing you have to remember that EDM stands for electro discharge machining or discharge machining. You need not be so specific about electric or electro. Both the words are right. As the name suggests, it is electric discharge machining. That is, electric discharges are coming from the electrode and machining takes place or the erosion takes place. That's why it is also called as the spark machining. Because of the spark machining happens, it is also called as the spark eroding. That is, because of the spark, the erosion happens. It is also called as the burning and die sinking or wire erosion. Die sinking, wire erosion. Now, why it is called the die sinking? Because EDM is popularly used for your mold making, die making, mold making and die making. Because molds or dies or the cavities are hard, and then conventional machining fails, so you have to go for EDM. So here the electrode shape and size is of the cavity which is to be machined, and then that electron penetrates, or we say electrode sinks down. Electrode sinks down the workpiece, and that's why the name is die sinking. Sinking because it is going down while cutting, and die because it is popularly used, or majority of the times it is used for machining the dies. And wire erosion is nothing but a special application, that is wire cutting. So the material is from the workpiece by a series of rapidly recurring current discharges between two electrodes, which is separated by a dielectric liquid and subject to an electric voltage. You are applying a voltage, a high voltage, for a temporary short time, and you get a very high voltage again for a temporary short time. And during that high voltage, a spark is generated again for a very short time. And because of that spark, the erosion of the workpiece takes place. Erosion of the workpiece takes place. One of the electrode is called as the tool electrode, or the tool or the electrode, and other is obviously your workpiece. As I have been telling again and again that this is used where the workpiece is conductive. The workpiece is conductive. Here you have to control the distance between the two electrodes. Now two electrode means one is your copper electrode and another is your workpiece. The workpiece is called as the electrode here. This sentence is important as the distance between the two electrodes is reduced. Means the distance between the electrode and the workpiece, the current intensity becomes greater than the strength of the dielectric is nothing but a coolant what you are using, and it breaks. So once the dielectric breaks, dielectric means it is a kind of a liquid which is between your electrode and workpiece. The current is current flows. It's like a short circuit. Current flows from the electrode to the workpiece. It's like a shorting. So this phenomenon is the same as the breakdown of a capacitor. And since the current flows, the material is removed uh, from both the electrodes. Now both the electrode means your copper electrode as well as workpiece. Now we have a technology, or we are applying our engineering knowledge in such a way that this material is removed less at the copper electrode and the material is removed maximum or the more from the workpiece. This is what you have to see. See, the erosion will occur at both the places. Your workpiece will also erode as well as your electrode will also wear. But we have to see that Your electrode wears very small and your workpiece wear more. Once the current flow stops, because the current is for the moment, then new dielectric, because the dielectric is flowing, new dielectric is conveyed between the electrode, two electrodes. Whatever material is removed, that is called the debris, is flushed away, and then that opens the circuit and no erosion takes place. So that time the electrode moves up and that creates a wide gap. And because in this gap your material is flushed away. Then again electrode comes down, the dielectric is broken, current flows, spark is generated, material is eroded away, and this keeps on going. That is, electron keeps on jumping up and down, up and down, down. So when it comes down, electrode, that time the spark will be generated, the current will flow, voltage will be generated, and the material will erode. Then when it goes up, hmm, it will be open circuit, the debris will be flushed away, and this keeps on happening, thereby eroding the material. So what you have to remember here that medium is used for hard metals. It is used for electrically conductive, which I have been telling you. Any metal which is electrically conductive. That's all. So even if the metal is soft, but it is non-conductive like plastic, it cannot be machined. Now this diagram you can copy, and try to understand this diagram. So by now you are understood that there is a workpiece which is kept in the dielectric fluid. Now this is a cavity which is to be machined in the workpiece. The cavity will be machined as per the shape of the electrode. The workpiece is connected to the positive and electrode is connected to the negative. And this is called the polarity, and this polarity can be reversed. So you have a rectifier control, then you have a current control, and you have servo control. Now rectifier control means it will convert your AC supply to DC supply. Current control is you have option to select the voltages and the current. That is, if you use high current, then material removal rate will be more. If you use small current, then material removal rate will be less. And of course, correspondingly, voltage will also get selected. These are the capacitors for filtration, that is RC circuit. You know that if there are some ripples, DC ripples, then it can be filtered out. And there are different circuits. So most popular is RC circuit, that is resistance capacitive circuit. So rectification is current and voltage control, and another is servo control. Servo control is nothing but that is moving your electrode up and down. You have to move your electrode up and down. So that is the servo control. And this up and down movement happens very fast. So your servo control should be capable of lifting the electrode up and pushing it down to the desired position. That's why this servo control plays very important role. See, the braking, lifting should be proper. The brake should be applied in such a way that there is very small gap, because if this electrode touches the workpiece, that means the shorting will happen. It will get short. At the same time, it shouldn't heat up too much. So this gap, electrode gap, hmm, has to be controlled precisely. That is possible only because of the servo control. What are the EDM components? This is at the center. What we are going to do, that is EDM machining chamber. I suggest you draw this diagram also quickly. So you have a machining chamber at the center. And you have some system to hold a workpiece. Then the function of servo mechanism, that is servo control, is to maintain the constant gap between the workpiece and the electrode. Then you have dielectric system. So dielectric system helps to maintain the temperature, to cool the workpiece, as well as to flush away the debris or the chips. And there are different types of dielectric system. Then another important is power supply. The function of power supply is to generate the current and obviously the voltage, and the wave is made up of on and off time. On and off time. Like suppose if I talk about a square wave, so like this is your on time, and this is your off time. Again, this is on time, this is off time, on time, off time. So in on time, the current will flow, the machining will happen. In off time, current will not flow, there will not be spark, no machining. So that off time is generally used to flow the to move the debris, because if the debris or the chips are trapped between the electrode and the workpiece, then shorting will occur, and the electrode will keep on machining the chips, that is debris. It will not machine the workpiece. So that's why it is very much essential to remove the chips. And this machining of the chips is called secondary machining in case of EDF. So this is what I discussed in this figure. The current density is in the order of 10,000 ampere per centimeter square. See, we are talking about so much high current. That is in 1 centimeter square. 1 centimeter you can imagine from here to here, maybe 1 centimeter by 1 centimeter. So this in so much of area, 1 centimeter by 1 centimeter, you can get 10,000 ampere. And if you talk about the power density, then power density can be as high as 500 megawatts per centimeter square. This much is possible. Of course, this much is not required. The gap between the electrode and workpiece, that is called the spark gap, varies from 5 microns to 50 microns, or even sometimes more also. Sometimes it is zero point 0.1 to zero point 0.2 or zero point 0.5 up to 0.5, that is 500 microns. So generally, if the gap is more, if the spark gap is more, then the finish is rough. And if the spark gap is less, then the finish is good. And obviously, if the finish is good, then material removal rate will be less. So if you are keeping very small spark gap, then your material removal rate will be less, but your finish will be good. If you are keeping more spark gap, then your material removal rate will be less, and if you are keeping more spark gap, then material removal rate will be high, but the surface finish will be less. We have to have a trade-off. The dielectric force that is 2 kilogram per centimeter square or even less. It should be capable enough to flush away the debris, the main function. As I told the working principle, that's there is a tool, there is a working material, that both are conductive, both are connected. One is cathode and one is anode. So depending upon where to remove the material, we connect the polarity. Like suppose if you connect workpiece to positive and electrode to negatives. So the electrons which are removed from the electrode, they carry negative charge, and since the workpiece is connected to positive, the negative charge electrons will be attracted towards the positive charge workpiece, and the erosion will occur because of the high speed moving electrons. Now, if you connect ulta, that is suppose electrode is assigned the positive polarity, and if the workpiece is assigned negative polarity, what will happen? The electrons which is moved, from the workpiece will rapidly go to the tool. Will rapidly go to the tool. Hello. Uh, कुठून? Uh, हो. Okay. अच्छा. कुठे? म्हणजे म्हणजे मला एकट्यालाच की मॅडमकडे सगळ्यांना. अच्छा अच्छा. कारण परवा वगैरे करेल ना, कारण श्रद्धाच उद्या ऑफिस असेल. तर म्हणजे बुधवारी बुधवारी शक्य आहे. आणि काय माहिती मोबाईल वगैरे आणि मॅडम हा एक मिनिट. मिळालं. हा मला माहित आहे. हा कारण ते हा आणि अकाउंट नंबर बघा 683,001. 683,001. हा आणि 9,346.07 ना. हा हो. आता मग मी देते, तुम्ही तिकडे मॅडमकडे जाऊन लगेच मला सांगा. हा and we are using, dielectric as kerosene or deionized water, that is used as the dielectric medium. And then electrons are emitted, then they are directed towards the workpiece and the material is removed. So actually the erosion occurs because of the high speed electrons, and I want to show you this diagram. See this. This is what is I was talking about on time, and this is your off time. This is on time and this is off time. Okay, this is what we are told is connected to negative, workpiece is connected to negative. So the machining will happen only during the on time. On time. Off time there is no machining. So we will discuss more. Sorry for the disturbances. If you have any doubt, you can ask. Otherwise, you can enjoy your break.
Thank you, sir.
Yeah, thank you.
Thank you, sir.
Thank you.